Thank you. It's a pleasure to be here and talk about the organic yields and yield trends in the Wisconsin Integrated Cropping Systems trial. Two of the co-authors are here at the conference, John Hall and Janet Hedke. Unfortunately, Josh Posner, the real head of this project, was not able to make it. He's undergoing chemotherapy for Hodgkin's lymphoma. Fortunately, he's doing well and teaching his courses and meeting with his grad students, but didn't feel he could make the trip. He did want to counteract some of the impressions you may have of Wisconsin from the recent news. Wanted to let you know that Wisconsin is in one of those darker orange states that Kathy showed you as higher organic participation, and it's also dark green in the 2008 survey that you can get on the table out there. I thought it was a little ironic that Josh wanted to downplay the protests here, because really the Wisconsin Integrated Cropping Systems trial was born out of some of the turmoil in agriculture in the 80s. And he and John Hall put together a coalition of stakeholders that were interested in the controversy of sustainability of the conventional systems versus organic and versus the low input systems. And they secured funding from the Kellogg Foundation initially, and then more recently from the ARS and the National Dairy Forage Research Center. I need to talk a little bit about our interpretation of a cropping system. This audience seems to be more familiar than most with the term, but we're really talking specifically about a set cycle of crops and a management philosophy such that we would have a conventional philosophy or an organic philosophy or a low input philosophy and so on. And the importance of that, as Jim mentioned, is that it really gives you some flexibility. You can't put together treatments that are going to last and be relevant for 10 or 20 years, and you really have to have an iterative approach to your systems. So there are three cash grain systems that were devised by the committee that John and Josh had put together. CS1 is a continuous corn system with a conventional high input type philosophy. Our second system was soybean corn with medium inputs, and the third system was soybean winter wheat with a green manure crop, and then corn. Started out as a low input system and quickly became strictly organic. I want you to note that push the wrong lever here. 1, 2, and 3 also refer to the number of phases in the cropping system. So even though I'm going to use these acronyms CS1, 2, and 3, if you look at the 1, 2, and 3, you can tell what system we're talking about. And that really carries on into the 3 forage systems for CS4, where we have 3 years of alfalfa and then corn with the conventional high inputs philosophy. It doesn't hold true for CS5, unfortunately, which is our second organic system, which is oats underseeded with alfalfa and then a full year of alfalfa followed by corn, with again starting low external inputs philosophy and quickly switched to organic. Our final system is a rotationally grazed pasture. The design and analysis of crop rotation studies is not a simple matter. I won't spend a whole lot of time talking about the details, but if you want to read up on them, check out Foster Katie's article in the Agronomy Journal in 1991. One of the key things that we do need to spend a little bit of time on is what we mean by a staggered start in the crop cycle, because when we look at the trends, the yield trends, we need to do that on a cycle basis. And so, for example, in CS3 here, our organic cash grain system, there are 3 plots assigned in each rep to that system. We bring in the first plot in the soybeans in 1990, but the other 2 plots are in filler corn to keep that corn background. You recall in that previous slide we had the uniformity year of corn. Then in 1991, when this plot, or really represents a field, switches to winter wheat, we bring in the second plot of soybeans, and the third plot is still in filler corn to keep that corn background. What that does then is give us 3 initial points to start the rotation, and so we're getting repetition in time as well as space. The other thing to point out here is when we do our analyses, we're going to look at the mean yields, and that'll give us some information for sure, but there is a problem. When we look out here to 1993, if we compare corn to corn in these 2 systems, they're not the same length. The soybean corn system has gone through into the second cycle, so this corn is representative of the second cycle, whereas when we look at the organic system, that corn is representative of the first cycle. So in reality then, our rotation effect is confounded here with the comparison, the length of the rotation effect. If we try to analyze by cycles, we go diagonally here, you'll see then that because of the unequal lengths, we can certainly get some information, but it'll be confounded with years because they, again, are not the same length. So we'll also end up with some problems with statistical repeated measures, which introduces correlations. We end up with heterogeneous errors. Our way of handling this whole big problem is to analyze each system separately, and we'll use proc mixed and SAS, which has the capability of using random coefficients to take care of these problems. We'll do the means and trends separately, as we talked about, and we'll use error bars at the 10% level in order to compare between the different systems. This is a picture of the Arlington site that we conducted the research at. It's typical of the upper Midwest. You can see gently rolling soils, medium to high organic matter, fairly high fertility. The other thing to note here is the large plots, as a number of these system trials have used. They're nearly 3/4 of an acre in size, so that we use fields or farm scale equipment. And the trial was conducted at 2 sites really. Also, besides the Arlington, we used a site at Elkhorn. That was owned by a county, and it was sold, so that we have a much shorter record there. And the results are really similar to Arlington, so today we'll just concentrate on the Arlington results. These results, again, we need to focus on that we're looking simply at the productivity aspects of sustainability. The overall purpose, of course, of the trial was to look at sustainability, but the focus here will be on the mean yields and are there any yield trends. When we look at the corn results, you see we're looking in bushels per acre. We didn't go down to 0 so that we could see some of these differences and the width of these bars a little better. And we see then the corn in the organic grain system averaging 143 bushels per acre and 166 bushels per acre in the forage system, the organic forage system. These are excellent yields when you consider that the USDA projection for 2011 for corn yields is 162 bushels per acre. But then too, on the other hand, our conventional corn and the corn-soybean system did out-yield these organic systems by 8 to 20 bushels per acre. And we can see that's statistically significant because these error bars do not overlap. These error bars are split so that the point between the 2 colors is the mean, and half of the 10% LSD is on either side of that mean and represented by the green or the brown. When we see these differences, the immediate question that I have anyway is, are they going to be consistent? Here we have 18 years of data showing that these differences are there, but they're not huge. Are the organic systems catching up to the conventional system, or or are they falling further behind? When we plot out the yield data for each year, beginning in 1992 when we had the first time for having corn in all these systems, we see quite a bit of scatter. The green triangle and green line represent the corn in the organic grain system. The blue circle, the blue line, the corn in the organic forage system, and then the red, of course, being the conventional corn in the soybean corn system. Out of all this scatter, we also see that we have a linear trend. There wasn't any curvature statistically in these lines. And that tells me two things. One, we didn't really have any startup or transition period that some people talk about. They seem to jump right into the straight trend. The other thing is that we don't have any real fall off out here at the end, indicating that our soils are maintaining their productivity. You can do a lot of soil quality measurements and all these other things, but really one of the best measures of how that soil is doing is how well it's producing, and we don't see any drop off after 18 years. There does appear to be perhaps a little bit of difference in the steepness of these slopes, and so I plotted these out a little more specifically, and here you see the trend in bushels per acre per year over the 18 years. And again, these data were done by cycles, and so we compare likes by likes. One of the things here right off, you see we have about a bushel per acre per year improvement in the organic grain system, positive, and that it doesn't reach down to zero here, so we're significantly above zero. We have 1.5 bushel per acre per year in the organic forage system, but then we're clear up to about 2 bushels per acre per year as a point estimate for the conventional soybean corn system. There is quite a bit of variability here, as you saw from the year-to-year slide that we just saw, carries over into our cycle analyses. And it would appear perhaps that the organic systems are much more variable than the conventional system. That's a little bit misleading because just like we talked about, they're different lengths. We have 10 cycles already in the conventional system, whereas we only have 6 full cycles in our 3-year organic systems. The other thing, again, of course, when you see these overlap, these confidence intervals overlap, even though the point estimates, the slopes were different, they're not statistically significant. Now's probably a good time to start talking like the other groups did about why these mean yields were slightly lower and our slopes were slightly less. As the other speakers mentioned, weeds are one of the big nemesis of the organic systems, and we found that to be particularly true in the wet years. We're relying on mechanical weed controls, a couple of rotary hoeings, and traditional field or row cultivator. And when you have those wet springs like we've had a number of in the 18 years, it's just difficult to get that done at all, let alone timely sometimes. So that was the biggest problem. The other thing that we did run into was that when we switched from having treated seed, the requirements for the organic changed. We had a couple of years of stand problems in the organic systems. Janet Hedke worked hard on that and found out a way that we're not having that much trouble anymore, but for several years there we did have poor stands and had to replant 1 year in the organic systems. Our soybean results are somewhat similar. We have excellent yields with the organic grain system, 47 bushels per acre over the 20 years that we've got in the mean yields, and fairly narrow error bars because of the large number of years, 80 observations going into each one of those means, and as a result, the difference between the organic and the conventional is statistically significant. Again, the question comes, are these differences going to keep increasing, or will they narrow? And it turns out they're probably going neither. We get pretty much flat lines. Again, here we have the green being the organic system and the red being the conventional system. And as you can see, pretty much almost by eye, there's really no trend there. And that really kind of fits with what a lot of the farmers are telling us, both from the organic side and the conventional side, is that they just aren't seeing the improvement in yields in soybeans that they're seeing in corn. We look at the wheat results. We have, again, very decent yields in our organic grain system, about 56 bushels per acre. I think the national average is in the mid to upper 40s. We don't have any other wheat system in the WICS trial to compare to, so I took a variety trial series from the same station to compare to, and you see that they're somewhat higher. Probably not the fairest comparison because they use much smaller plots which have much bigger border effect, and they also took the liberty of throwing out 1 year where they had near crop failure from their data. So, but what it does do is it gives us a chance to look at the trends, which I think are very important. And we see here, again, this scatter from year to year, with the green being the organic grain data and the red being the conventional variety trial. We see both are increasing, perhaps the variety trial a little more rapidly. When we look at the slopes directly, we see that that's probably true. We have about 9/10 of a bushel per acre per year increase in the wheat yields in that organic system, whereas the variety trial yields are increasing at 1.8 or so. The size of these error bars are such that right now they don't quite overlap, so you'd call those statistically different. I think if we had county yields or something like that, they'd be intermediate, and we probably would overlap, and you wouldn't be able to call those statistically different. Our alfalfa trial results show for the first year after establishment, seeding year +1, where we have a comparison that we can make within the WICS. We're getting, again, excellent yields with our organic forage system, 5 tons per acre. And again, fairly narrow bars because we have so many years and reps of data in these. The error bars being fairly narrow, you got to look close, but they do overlap slightly, so the slightly lower yields that we're getting with the conventional system are not statistically different from the organics. When we look at the trend, we see that we have a slight decrease here, the blue bars being the blue line and the blue circles being the organic forage system yields, the red being the conventional out of that CS4, where we do have an increase. But in order to see some of the variation, I put the vertical axis so it didn't touch 0, and that somewhat exaggerates this, as you'll see here. These slopes are very small. The tons of dry matter per acre per year for the organic forage system is a -0.03 of a ton per acre. It does, even though a fairly narrow error bar, touch 0, so it's not statistically different from 0, even though the point estimate is negative. For our conventional system, it's slightly positive, but again, very small, 0.04 of a ton dry matter per acre per year. They are small enough that the two are statistically different from each other. In summary, I think there's a little bit for all sides in this study that's for 20 years, 18 to 20 years really, of data showing our organic system, our organic systems are yielding well, but they're still somewhat below our conventional system, averaging about 90% of the conventional yields. When we look at the trends over time, which I would claim would be somewhat of a measure of sustainability and the productivity end anyway. We see that the trends are positive, or in the case of soybeans, level. And the point estimates of those slopes, those changes, show that the organic trends are less than the conventional, so they may be falling behind a little bit. But on the other hand, there's so much variability that we can't declare those statistically different. In the case of organic alfalfa, the trend seemed to be slightly negative, which would maybe imply a lack of sustainability, but it was so small that I think it'll be overcome with the trends and changes in management. So overall, push the right button again. Our conclusions are that there are challenges to the organic system, primarily in weed control, occasionally in some other instances, but they've proven to be sustainably productive in the 20 years of the WICS trial. And thus other issues such as the economics that are going to be discussed this afternoon, or the environmental impacts that will be discussed at another time, or some of the social issues, those can be key rather than worry too much about the productivity of these different systems.
Great.